Hello and welcome. In today's video, we're going to be reviewing how to evaluate all 6 trig functions around the unit circle without having to memorize the unit circle. All right, we're going to begin by doing a quick review of our trig functions. Now, if you're already familiar with your basic trig functions and your basic trig identities, feel free to skip forward into the video. Otherwise, let's dive in with these definitions. There are a number of ways to define the trig functions, but I'm going to do this with this mnemonic SohCahToa. Now, SohCahToa is talking about the sides in a right triangle. So here I have a right triangle. Again, a right triangle is a triangle with a 90-degree angle in it, and specifically talking about an angle theta that's acute. That's one of the smaller angles in that right triangle. Now, if you look at the sides of that triangle in relationship to that angle theta that I have drawn there, there are 3 sides. There's a side opposite of it, across from that angle theta. We're going to call that the opposite side. I'm going to abbreviate that OPP for opposite. There's the side that's next to it, the shorter side next to it. That's called the adjacent side, which I'll abbreviate ADJ. And then there's the long side across from the 90-degree angle. We call that the hypotenuse, which I'll abbreviate HYP. All right, with those definitions in play, the mnemonic SohCahToa is really talking about our 3 main trig functions: sine, which is abbreviated SIN, cosine, which is abbreviated COS, and tangent, which is abbreviated TAN. So the S is standing for sine, and it's saying that sine of theta is equal to, and then the O and the H is standing for opposite and hypotenuse, and this is a ratio of those 2 sides. So sine of theta is equal to opposite over hypotenuse. Very similarly, the C stands for cosine, and it's saying that cosine of theta, the A and the H stands for adjacent and hypotenuse. So it's adjacent over hypotenuse. And again, it's a ratio of those 2 sides. And finally, TOA stands for tangent is equal to opposite over adjacent. All right, let's put this into play with an example. So let's look at a right triangle, and we'll look at a classic right triangle from, say, geometry, a 3, 4, 5 right triangle. And again, one of those angles is a right angle. We're going to put in an angle, let's call it just A for now. And let's see if we can figure out what like sine of A or tangent of A is. So let's start with sine of A. So sine of A, again, is opposite over hypotenuse. So opposite from A is 3. And the hypotenuse, again, is the long side across from the 90-degree angle. So the hypotenuse is 5. So sine of A is 3 over 5. All right, so let's try tangent of A. So tangent of A is opposite. So again, across from A or opposite of A is 3. And then adjacent to A, again, not the hypotenuse, the adjacent side to A is 4. So in this way, tangent of A is 3 over 4. Now, in addition to our 3 main trig functions, we also have 3 reciprocal trig functions. These are cosecant of theta, abbreviated CSC, secant of theta, abbreviated SEC, and cotangent of theta, abbreviated COT. And these are just the reciprocals of our 3 main trig functions. So cosecant of theta is equal to 1 over sine of theta, or the reciprocal of sine. Secant of theta is 1 over cosine of theta, or the reciprocal of cosine. And cotangent of theta is the reciprocal of tangent, so 1 over tangent of theta. And the last thing that we're going to need before we can evaluate around the unit circle are these 2 special triangles, the 30-60-90 triangle and the 45-45-90 triangle. And we're going to have to remember the side lengths of these triangles. Now, these can be proportioned out to anywhere that you like, but for the unit circle, we always have a hypotenuse of 1. Now, the other 2 sides of the 30-60-90 triangle are 1/2 and root 3 over 2. And if you look at the 30-60-90 triangle, across from the 30-degree angle is the smaller side, and the smaller of 1/2 and root 3 over 2 is 1/2. And across from the 60-degree angle is the larger side, so we're going to put the larger of those numbers, root 3 over 2, on that side. Okay, now for the 45-45-90 triangle, again, we're going to have a 1 on the hypotenuse. Again, that's what the unit circle is all about. And on the other 2 sides, they're both the same, and it's both the number root 2 over 2. Now, the big thing that we need to remember here is that on the 45-45, we have that root 2 over 2. And the 30, 60, 90 has the 1/2 and root 3 over 2. And if we just draw it to scale, you'll see where the 1/2 has to go and where the root 3 over 2 has to go as well. Okay, so now we're ready to start evaluating our trig functions around the unit circle. We're going to start here with theta is equal to 30 degrees. So we're going to find, say, sine of 30 degrees, and then we're going to find cosine of 30 degrees, etc. Now, my number one thing on evaluating around the unit circle is don't try to memorize all the values around the unit circle. Just know those two special triangles and be prepared to draw them. So I'm going to start by just drawing my 30, 60, 90 triangle roughly to scale. So I'm putting in a smaller angle, 30 degrees, and a larger angle, 60 degrees. And now I do have to remember those two sides, 1/2 and root 3 over 2. I just need to remember those numbers, and then when I look at this triangle, I can see that 1/2 is the shorter side. It's going to go across from 30 degrees, and root 3 over 2 is the longer side. It's going to go across from 60 degrees. And again, for the unit circle, every hypotenuse is equal to 1. So now all I have to do is use this triangle and SohCahToa, and I can find my first three trig functions. So sine of 30 degrees is opposite. Opposite of that 30-degree angle is 1/2. Over the hypotenuse is 1, so 1/2 over 1 is just 1/2. Whereas cosine of 30 degrees is adjacent over hypotenuse, so root 3 over 2 over 1, which is just root 3 over 2. And finally, we'd have tangent of 30 degrees is equal to opposite, 1/2, over adjacent, root 3 over 2. And now we can simplify this down a little bit by flipping and multiplying this root 3 over 2. We would get 1/2 times 2 over root 3. And those 2's can cancel. And now we can multiply by root 3 over root 3 to rationalize this. And we'd end up with root 3 on the top. And then root 3 times root 3 is 3 on the bottom. So we end up with tangent of 30 degrees is root 3 over 3. All right, so those are our three main trig functions. For our other three trig functions, I'm going to erase this. And for those ones, we can just use those reciprocal identities. So cosecant is the reciprocal of sine. And reciprocal just means that you're going to flip the fraction upside down. So instead of 1 over 2, we'll get 2 over 1, or just 2. Whereas secant of 30 degrees is flipping cosine upside down, so that's going to be 2 over root 3. And again, we can rationalize this by multiplying by root 3 over root 3, so 2 root 3 over 3. And finally, cotangent of 30 degrees is flipping tangent upside down, and you can flip it down anywhere, and really it's best to flip it right here. So instead of 1 over root 3, it becomes root 3 over 1, or just root 3. All right, let's take a look at 240 degrees. Again, the same piece of advice is going to hold here, that the main thing you want to do is get comfortable drawing these pictures of these triangles. Now, 240 degrees, remember that angles start at the positive x-axis and then rotate counterclockwise. So we're just going to count out till we get to 240 degrees. So we're going to have to go 90 degrees to get the y-axis, 180 degrees to get to the negative x-axis, and then in order to get to 240, we're going to have to go another 60 degrees. Okay, so that's where my 240 ends up. It ends up down here in the third quadrant. Now, when we draw in our triangles here, we always need to remember to draw them to the x-axis. That's the number one thing that students mess up on, is they draw it to the y-axis, because in this case it might be closer. But we always want to draw to the x-axis. Okay? And now we're just going to label the sides of this 30, 60, 90 triangle. Now remember, the hypotenuse is always 1. Okay, so not a problem labeling that. And then across from the 60-degree angle is the larger side. So that's root 3 over 2. Okay. Next to the 60-degree angle is the shorter side, so we're going to put 1/2 there. Now, the other thing you need to remember when you start to go into the other quadrants, that these 1/2s and root 3 over 2's, they're x and y coordinates. So if we look at our x coordinate, for example, it's 1/2, but it's going backwards here, so it's actually negative 1/2. And similarly, that root 3 over 2 is underneath the x-axis, so it really should be negative root 3 over 2. Now, once we have this picture drawn, we can use SohCahToa. So if we want sine of 240 degrees, that's going to be the opposite side. So opposite of our angle is negative root 3 over 2. Over the hypotenuse, again, is 1. So this is just going to be negative root 3 over 2. Whereas cosine of 240 degrees is going to be the adjacent side, so negative 1/2 over the hypotenuse, which is 1, so just negative 1/2. Okay. Finally, tangent of 240 degrees is going to be opposite, so negative root 3 over 2 over adjacent, negative 1/2. Here the negatives are going to cancel and we're going to flip and multiply, so we're going to get root 3 over 2 times 2 over 1. The 2's will cancel, so we just end up with root 3. Alright, I want to make sure to do some examples with radians, so we do need to remember some of our conversions for radians. So remember that a full circle is 360 degrees in degrees, and in radians it's 2 pi radians. If we divide both sides by 2, we'll get that 180 degrees is pi radians. And then really the other ones that we need to know is that 60 degrees is pi over 3 radians, 45 degrees is pi over 4 radians, and 30 degrees is just pi over 6 radians. Okay, and I guess finally 0 degrees is 0 radians. All right, let's take a look at a problem in radians. So here we're going to do a problem at 3 pi over 4. So the first thing we need to do is figure out what quadrant is this going to land in. Well, we're starting at 0 radians. It's definitely bigger than that. And then 180 degrees is the same thing as pi radians. And because we're in fourths here, 3 pi over 4, what we want to do is take this pi and multiply it by 4 over 4. So pi is really the same thing as 4 pi over 4. And now we can see that if we're rotating to 3 pi over 4, we're going to fall short of 4 pi over 4. So 3 pi over 4 is short of 4 pi over 4 by pi over 4. Okay, so we're just going to draw this in. And again, we're going to label the sides. Now here we need to remember that pi over 4 is 45 degrees, so we just need to label the sides of a 45-degree triangle. Again, the hypotenuse is going to be 1. Okay. Across from 45 degrees is going to be root 2 over 2. And again, if we think about this as a y-coordinate, it's going to be a positive root 2 over 2. Okay. And then on the adjacent side is our x-coordinate, and we can see that that's going to be negative because we're here in the second quadrant. So it's going to be negative root 2 over 2. So all I have to do is draw this little triangle, and now we're ready to find our 3 trig functions. So let's start with sine of 3 pi over 4. And again, we can just look at this triangle. Again, as long as you draw it to the x-axis, you can use SohCahToa. And sine is opposite, so root 2 over 2 over the hypotenuse is just 1. And if you divide by 1, that doesn't do anything, so I'm not going to write over 1 this time. Okay, cosine of 3 pi over 4. That's the adjacent side to this pi over 4, so that's negative root 2 over 2. Okay, again, over the hypotenuse again is 1, so I'm not going to write that again. Okay, finally, tangent of 3 pi over 4 is opposite root 2 over 2 over adjacent negative root 2 over 2. Okay, and here we're dividing root 2 over 2 by root 2 over 2, so this should just be 1. But remember, one of those sides is negative, so it's actually going to be negative 1. Okay, so we found the 3 main trig functions. If we wanted the other 3 trig functions, of course, all we have to do is take the reciprocal of each one of these. All right, let's take a look at another radian problem, this time 11 pi over 6. So remember, we want to draw a picture here, so we need to figure out where this angle is going to land. So we start rotating around, and for pi, again, we need to get it in terms of the denominator here, 6. So we're going to multiply by this by 6 over 6, and we can see 11 pi over 6 is way past that. So if we start to draw this, it's going to go way past that. So let's look at 2 pi. Okay, again, we're going to multiply by 6 over 6, and 2 pi is going to be 12 pi over 6. So now we know that 11 pi over 6 is just going to be 1 short of that. Okay, so 11 pi over 6. In order to get all the way around, we would need to go another pi over 6 or another 30 degrees. And again, we're going to draw this little triangle to the x-axis. That is the number one key, is it always has to go to the x-axis. Once we draw this triangle in, all we have to do is label the sides. Again, we're going to always label the hypotenuse 1. And then we do need to remember these two sides for the 30, 60, 90, 1/2 and root 3 over 2. Root 3 over 2 is the long side, so it should go next to the 30-degree angle. And across from the 30-degree angle is the shorter side, so we're going to put 1/2 there. Now again, that 1/2 there is a y-coordinate, so we really want to write that as a negative 1/2. Once we label that, now we can use SohCahToa to figure out sine and cosine. All right, so now all we have to do is use SohCahToa to find sine of 11 pi over 6. Because again, opposite of our little angle here is negative 1/2 over the hypotenuse of 1. Divided by 1 doesn't do anything. So sine of 11 pi over 6 is just negative 1/2. Whereas cosine of 11 pi over 6, using the ka in SohCahToa, is the adjacent over the hypotenuse. So the adjacent side to 30 degrees is root 3 over 2 over the hypotenuse of 1. Again, dividing by 1 doesn't do anything, so I'm just going to do root 3 over 2. All right, so in this problem, I only found sine and cosine, but we could find tangent using opposite over adjacent, and then we could find the other three trig functions by just taking the reciprocal of these three trig functions and then maybe simplifying and rationalizing if necessary. All right, now the last thing we need to look at on the unit circle is the quadrantal angles. Now the quadrantal angles are a little bit different because if you try to find, say, sine in 90 degrees, and you draw in that 90-degree angle, and then you try to draw a right triangle, you really can't, okay? There is nowhere to draw this right triangle anymore. So we need to do a slightly different thing here. All right, and this is going to be the case not only at 90 degrees, it's also going to happen at 180 degrees, or 270 degrees, or back at the beginning 0 degrees, or 360. Okay, all these are called your quadrantal angles. Now in radians, that's going to be 0, pi over 2, pi, 3 pi over 2, or rotating all the way back around to 2 pi. So for these quadrantal angles, we're still going to use SohCahToa, and we're just going to draw a little triangle in our first quadrant. Okay, and we're going to label the two sides on that triangle as across from it is the y-coordinate and next to it is the x-coordinate. And we've kind of gotten into this before as we're labeling positive and negative sides. And again, the hypotenuse in all of these is just 1. Okay, and now we can use SohCahToa to refigure out sine and cosine in terms of x's and y's. So for example, on this one, sine of theta is opposite, so y, over hypotenuse of 1, so just y. Whereas cosine of theta is adjacent, x, over hypotenuse of 1, so just x. And tangent is opposite y over adjacent x. Okay, and again, these are our three main ones off the SohCahToa, and then we can do the reciprocal functions for our other three trig functions. All right, so now all we need to do is label x and y coordinates at these quadrantal angles. So on the x-axis at 0 degrees or 360 degrees, the x-coordinate would be 1, and the y-coordinate would be 0. Okay? At 90 degrees, x is now 0, and y is 1. At 180 degrees, x is negative 1, and y is 0. And at 270 degrees, x is 0, and y is negative 1. So now with all of that, if we want to find sine of 90 degrees, sine is the y-coordinate at 90 degrees, so we look at 90 degrees, and our y-coordinate is 1. Okay? If we wanted cosine of 90 degrees, that would be our x-coordinate at 90 degrees, so that would be 0. Now if we wanted tangent of 90 degrees, we would get 1 over 0, but 1 over 0 doesn't exist, so we could write DNE for doesn't exist, okay, or just write out does not exist. All right, let's take a look at another quadrantal angle problem from scratch. So here I have cosine of pi. So again, my first instinct here is to draw a picture, and I'm going to draw pi. Again, that's going back here in 180 degrees, so it's landing on the x-axis. And I might start to worry because I can't draw a triangle, and that's typically how I want to approach these. So I can't remember off the top of my head, is cosine equal to x or y? What's going on here? So again, what I'm going to do is just draw a little picture in the first quadrant, and I'm going to use SohCahToa to figure it out. So next to that angle theta is x, across from it or opposite is y, and again the hypotenuse on the unit circle is always 1. So with that little picture, I can quickly figure out that cosine of theta is equal to the adjacent side x over the hypotenuse 1, so it's just the x coordinate. And now if I want to find cosine of pi, I just need to label this point on the negative x-axis. Again, it's going to be a radius of 1, so it's going to be negative 1, 0 as my 2 points. So cosine of pi is my x-coordinate, so it's just negative 1. And as always, please take a moment to like this video and subscribe to my channel.